Hi there. It's morning, so there's better light. I'll speak softly so it doesn't distort the sound. But I'm working on the rig. I've got these magnetic rotary encoders, as you can see. You can see the axle with a little chip next to it. There's a wire, and then here's a breadboard, which can definitely be smaller. That takes a signal from the magnetic rotary encoders and turns it into a serial signal. And I was just trying to pick that up with this PIC microcontroller, which is not really necessary. You can also send it directly to the computer through the serial connection. But I'm beginning to get a bit sick of these PIC-X chips because they lock themselves up if you program the serial output and input. If you use that, then they become inaccessible for programming, which is of course quite let's say annoying, because you can catch that type of mistake by adapting the compiler. It's let's say the whole system now is complete. These are the buttons that you use to control the apparatus, the heliostat, solar concentrator by hand if you want. This is the motor controller. This would be the chip for interfacing with the computer. You could also use a complete computer like a Raspberry Pi or something like that. This is this chip and the microencoders, magnetic encoders. They turn the whole thing into a servo controlled rig without having much, let's say, consideration for what the engine or what the way is that this rig moves, which is a good thing, because then you can separate the two. You can basically have motors of your own choosing. These are DC motors which can be reversed, but you can have all kinds of different motor systems. I want to develop this into a, let's say, a plug-and-play system which also hooks up to a website. And to do that, I was basically trying to catch the data from the encoders by the PIC-X microcontroller. And once again, I stumble over the, let's say, the sensitive nature of this whole setup, which is, I think, crap. I think that there should be, let's say, fully robust systems for R&D for amateurs like me. Although I'm slowly turning into a professional, there's all these obstacles that industry doesn't have because they simply spend 600 euros on some package, which of course doesn't have that value except when you have a business. So there's all these barriers between individuals producing useful stuff, because with this little chip I can also have my thermostatically controlled cooker for my, let's say, rice cooker, all my other stuff that I want to make. I use these devices for, and they're simply buggy and relatively expensive. So hopefully the 18M2 still works. I couldn't get that going in the same kind of unpredictable fashion, even if you have nothing else connected to it. It didn't want to give a sign of life. But if it does work, and I might have several others of those, then I can once more attempt to catch the data from the let's say the heliostat, or from this 2-axis frame, servo controlled frame, you could say, and the purpose is then that you can have multiple of those frames driven by a single microcontroller. These frames will be autonomous, and they have to have, or they're basically able to determine their position relative to their how they're fixed. So with some calculation, you can then calculate exactly what the position should be. That depends for a part on the reliability of let's say the construction itself. But overall, this is, I think, an extremely useful device, which is working, by the way. Only the catching the data and doing something with it by a microcontroller is not working at the moment. But if you use a computer and you use a separate motor control system, then you don't have a problem. So the ultimate goal is still to have this visible by a webcam and maybe controlled by your mobile phone or something like that. You pull up a website, you have some buttons that you can press, and you can interact with it and see the result. Of course, the goal of the whole project is to build a automatic sand melting rig that can construct buildings by melting sand and pouring it in the right places. Of course, this is an essential part of it, and this is even this is 10-bit. Of course, the next step would be the 12-bit. But I'm looking for people that want to invest. I got one request for somebody that was working with these magnetic rotary encoders and didn't get his Arduino going. I'm not sure what the speed is of the Arduino, whether it's able to catch the data from the magnetic rotary encoders, because it's quite fast, high rate, because they can also be used to determine the position of a motor as it is turning. So you have electro motors turning at high speed, and you want to know exactly when you have to switch on different coils in the motor, so it's used optimally and it's not breaking. There's a timing issue there, a timing challenge basically, and if you know what's going on with the axle, you can do that very accurately, and these devices are used for that. So that's why they can put out information at a very high rate to be able to process that and come back. And anyway, but so now you can see it at daylight. So this whole device would, I think, visibly have a motor there. I think I'll keep that. A motor here is also what I'll keep, and then it would be a little printed circuit board somewhere here with I think maybe 2 chips on it, and then of course two connected chips for the position sensing. So it would be much leaner than what you see now, and there would be much less wires and all that stuff. But this is simply a prototype. Anyway, I hope this is interesting, and thanks for watching.